Hello, 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 ladies and gentlemen. Welcome back to more of the 2001 Pascal paper. We're looking at question number 16 in this video. In the diagram, all triangles are equilateral. The total number of equilateral triangles of any size is... Okay. Now, this question actually reminds me of the sort of thing you might see occasionally posted on the internet, or I think you might see it every once in a while on one of those timed IQ tests. When really there's not that much going on in terms of, I don't think we're going to have any equations here. It's just a question of, can you parse out all the triangles in this diagram? Now, when I see a question like this on a math contest, I'm inclined to believe that the answer is the highest of the potential values. So just reading the answers here, which they give in ascending order, E28, I'm going to suspect E28 is the highest number, just because without a whole lot of math and calculation here, it's just a question of, can you read through the picture? And so there's no way to, there's no real way to know, am I done looking? You can try and rule out certain triangles of certain sizes, but, there's no natural, aha, that's the end point that you should get, like the same way you do with a calculation. You've got a quadratic there, use the quadratic formula, you get x equals something, there you're done, and you could circle that answer. This is more of a counting, how do we know we're finished counting question. So the easiest way to know we're finished counting is, aha, we counted 28, we don't need to look for more, we got the maximum number they were given us. Okay? That said, the answer might not be 28, sometimes it's not the highest, because they know that some people will just bubble in the highest and move on. So let's get to actually counting these triangles here. Okay? So our diagram is sort of two big equilateral triangles stapled together. I have a feeling I'm going to be drawing this picture a couple times. Alright, I think that's it. So if we wanted to try and do this methodically, what we might try and do is say, well, how many have side length of 1? How many have side length of 2? How many have side length of 3? And I don't think we're going to get anything with side length of 4. Just looking through here, most of our lines, no line is more than 4. So let's break it down into cases. And the possible side lengths are 1, 2, or 3. So for the triangles of size 1, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 of size 1. Okay, now let's redraw the picture in case we need to come back and double check our counting. That's an awful version of the picture. Now, counting triangles of size 2, that's going to be a little different. And we need to think of a good way to count them. Okay, so the ones of size 2 look like this. So I think what I'm going to do is I'm going to count by this middle square. This middle triangle, it can't be anything on the side. And that's sort of the only limit, because we've got this one here with this center, and then we have this one here with this center too. Got a third one here. Here's a fourth one. 5, 6, 7, 8. 8 of size 2. So already we know we have 18 plus 8, so that's 26 triangles. If we look at our potential answers, we're down to 26 or 28. It can't be 24. We have found more than 24 distinct triangles, equilateral triangles. So we could even take a guess, but we're not done yet. We've got more triangles to count. We've done size 1, size 2. Now we're up to size 3. So we'll redraw our picture just one more time. Okay, but the ones of size 3, when we draw out a sample one just to work with, well, those have been staring us in the face the entire time. There's 1, and then there's 2. There's only going to be 2 of them. Okay, even if there supposedly weren't, we've got 2, so that's a total of 28. I don't even need to look for another one because I have a total of 28 triangles that I've counted. So 18 plus 8 plus 2, that's going to be 28 triangles. That's the largest answer. That's E. We don't need to look for more. We'll make a little note down here. Right. The only thing we need to do, if we're going back and double checking our work in this contest, is make sure that each of the 18, 8, and 2 triangles, each of the total 28 equilateral triangles we got was equilateral and unique, that we haven't double counted anything. Now, thanks to our notes, makes counting again and checking later in the contest a breeze. So we know, and we're very confident, that we got a total answer of 28. And that was, just double checking, it was E. All right, so interesting little question, and hopefully question number 17 is just as interesting. We're going to take a look at that in the next video.